Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit. Alright guys, let's do this problem that says the uniform rod of length L and weight W is supported on the smooth planes. Determine the position theta for equilibrium. Neglect the thickness of the rod. So this problem requires a lot of trigonometry, and we're going to be doing a lot of sines and cosines with these angles. So what's important is that you have your cheat sheet with your trigonometric equations next to you, and also that you're very neat and don't mess up your angles because it has a lot of letters. Okay, so I'm gonna be myself as steady as I can, and hopefully you guys understand it. So let's get started. First, like always, let's draw the free body diagram. We know we have a reaction here, a reaction here. We know we have the weight right in the middle, going straight down. Now this reaction, the angles phi, and this letter is called psi, my Greek alphabet from doing so many problems. Psi and phi, let me write this down here. Psi, phi, and theta. Theta. So this is our free body diagram. Let me also call this point A, and I'm going to call this point right here point B, the point where this happens. So let's get started. Now I'm going to start by doing the sum of the moments about B. So counterclockwise is positive, sum of the moments at B is equal to 0, and it is equal to, first from B we have the moment created by the weight. The weight is going straight down, right? So the weight is trying to turn the whole thing clockwise, so it's negative. And the distance from here, going straight down, from here to B is equal to L over 2 cosine of theta. Now A has two components, a y component and an x component, and they're both creating respective moments. So A cosine of phi is the y component, the component that's going straight up, and it's trying to turn the whole unit counterclockwise, so it's positive. And the length from here to B is equal to L cosine of theta. And then the x component of A, which is A sine of phi, and it's trying to turn the distance from here to B, and that distance is given by L sine of theta. So this is one of our first equations. If you notice, L is in all three terms, and you have a 0 on the other side, so you can easily divide both sides by L and take it up, and that will simplify the equation. So simplifying the equation, I have the first term, which is minus W over 2 cosine of theta, plus, and on the other two terms I'm going to factor out the A, so I have A times cosine of phi cosine of theta plus sine of phi sine of theta. Cosine of phi, cosine of theta, sine of phi, sine of theta. I'm going to move a little slower and double check that I don't mess up any letters, because I don't want to confuse you by making mistakes. Now from trigonometry, you should look at your trigonometric cheat sheet, or if you memorize it, good for you. You know that the cosine of phi minus theta, the cosine of two angles, of the difference of two angles, is equal to cosine of phi cosine of theta plus sine of phi sine of theta. You know this from trigonometry. So we're going to replace that. And we're gonna say that 0 is equal to minus W over 2 cosine of theta plus A cosine of phi minus theta. And now we solve for A, and we have A is equal to W cosine of theta over 2 cosine of the difference between phi and theta. And we have one equation. Many more to go, guys. So if we do the same thing, assuming counterclockwise is positive, some of the moments around A, the other point, we're pretty much going to go through the same steps to be able to solve for B. So that's what I'm going to do. Again, from A, actually, I'm going to do this on a different page. I want to do this on a different page, that way we maintain the neatness. So, like I said, this is A. So, sum of the moments about A is equal to 0, assuming counterclockwise is positive, and it's equal to the weight. How to redraw this? The weight times L over 2 cosine of theta, because that is the distance from here to A. Now B, remember B was something like this, so it had a y component and an x component. Now the y component is trying to turn the lever from x, from this dot right here to all the way to A. So it is B cosine of psi times that distance is given by L cosine of theta. And it is negative because it's trying to turn it clockwise. And the weight was positive because it's trying to turn it counterclockwise. So your signs are important. One wrong sign can ruin this whole thing. And then the x component is trying to turn the distance from here to A, and it is equal to B sine of psi, which is the x component of B, times L sine of theta. And it's positive because it's trying to turn it counterclockwise also. So, as you can see again, L can pretty much come out. L becomes a little bit irrelevant because 0 is on the other side and L is in all the terms, so dividing by L cancels it out. And we get that 0 is equal to the weight over 2 cosine of theta plus, I'm going to factor out the B on these two terms and say sine of psi sine of theta minus cosine of psi cosine of theta. Now, from trigonometry, we know that cosine of psi plus theta is equal to sine of psi sine of theta minus cosine of psi cosine of theta. So I'm going to replace that. 0 is equal to W over 2 cosine of theta plus B cosine of psi plus theta. And if you solve for B, you get that B is equal to W cosine of theta over 2 cosine of psi plus theta. And we have a second equation. So we have A and we have B in terms of the other angles, in terms of the 3 angles and the weight. So let me add another page. I want to keep this organized. And now we're going to basically relate these two equations that we just found together, A and B. And how do we relate A and B? Let me redraw this diagram again. This is phi, this is psi, this is the weight. If I wanted to relate A, the force A and the force B, notice that you can do that by doing the x-axis. So sum of the forces in the x is equal to 0. and it is equal to b sine of psi minus a sine of phi, which is the x components, the x component of a and the x component of b are the only forces that are going to the left and to the right. Simple enough, right? So now the two equations that we just found, which gave us a and b, we're gonna plug them in here and here. So let's get to that. 0 is equal to w cosine of phi over 2 cosine of psi plus theta. I don't know why I said phi. It was w cosine of theta, 2 cosine of psi plus theta, times all of this multiplied by the sine of psi. And this is for the first term. Let's do the second term, which is a. A is equal to w cosine of theta all over 2 cosine of phi minus theta times the sine of phi. All right. Now notice that there's a lot of things that we could simplify here because we have 0 on one side and we have a lot of repeated variables in the other two terms, such as the weight. The weight goes away. If you divide both sides by the weight, and 0 divided by the weight is still 0, cosine of theta can go away. 2 can go away. And I think that's pretty much it. So 0 is equal to sine of psi over cosine of psi plus theta minus sine of phi over cosine of phi minus theta. Now I'm gonna basically switch this term to the other side to be able to multiply. I mean, I'm able to multiply here, but I don't want to skip too many steps in this one because I don't want to confuse you guys. So this means that sine of phi over cosine of phi minus theta is equal to sine of psi over cosine of psi plus theta. And I'm going to basically multiply this by this, and I'm going to multiply this by this. That's what's happening next. I'm going to try and go over here, or actually start a new page soon. Sine of phi times cosine of psi plus theta is equal to sine of psi cosine of phi minus theta. Remember what we're trying to do, like never lose where you're trying to get with all this when you start thinking, man, this is getting confusing. We're trying to find theta. So that's what we're trying to isolate in this function. That's what we're doing all this. So let's keep going. I'm gonna start a new page just to remain as neat as I can with all these numbers. And I'm going to replace cosine of phi plus theta and cosine of phi minus theta back to what they were with the trigonometric identities that I showed you before that you should have on your cheat sheet. So 0 is equal to sine of phi times cosine of phi cosine of theta plus sine of phi sine of theta minus, this is the second term, sine of phi times cosine of psi cosine of theta minus sine of psi sine of theta. That's a bracket, I swear. Okay, so now what I'm going to do is I'm going to multiply the terms. And you're going to see that I'm going to be able to add two of them together. So 0 is equal to sine of psi cosine of phi cosine of theta. This is the sine times the first term. Now sine times the second term is going to be sine of psi, sine of phi, sine of theta. Now this is this term times this term. Now I'm going to multiply this term times this term, which is minus sine of phi cosine of psi cosine of theta, plus that's this times this, and now I'm going to multiply this times this, and it's going to be sine of phi sine of psi sine of theta. Now, as you can see, these two terms are exactly the same, right? So you can just add them together, and that will be 2, it's the 3 sines, sine of psi, sine of phi, sine of theta, is equal to sine of phi cosine of psi cosine of theta minus sine of psi cosine of phi cosine of theta. What a long problem, right? We're almost there, guys, I swear. So remember what we're trying to do. We're trying to isolate theta, right? That being said, notice that in the terms on the right, actually, let me trace back a second. I just want to explain exactly what I did. I added these two terms together because these two terms are exactly the same. So it's 2 times that term. And then the other two terms, I send them over to the other side, the side with the 0. And then I just wrote down this in the equation. Now, the other two terms, they both have a common term, which is cosine of theta. And I'm going to use that to my advantage. So I have 2 and the 3 sines, sine of psi, sine of phi, sine of theta is equal to cosine of theta, sine of phi, cosine of psi, minus sine of psi, cosine of phi. This is starting to look a little better. Those of you who have a lot of practice with this are starting to see where I was going with this. Now, I'm going to basically send this cosine of theta to the other side, dividing, and I'm going to send these two terms to the right, dividing. And it's going to look something like this. 2 sine of theta, because this term stayed, over cosine of theta, because this term went to the other side, is equal to sine of phi cosine of psi minus sine of psi cosine of phi all over sine of psi sine of phi. Now, did I do this right? Yeah. Okay. So you know that sine of theta over cosine of theta is equal to 2 tangent of theta. And you know that I'm going to distribute this term and divide each one by it. If I divide the first one, you know that sine of phi divided by cosine of phi goes away, and then you have cosine of psi divided by sine of psi is equal to cotangent, right? Cotangent, or tangent inverse or cotangent of psi. And then for the second one, minus sine of psi over sine of psi goes away, and cosine of phi over sine of phi is cotangent of phi. Starting to look a little prettier now. We're almost there. So now you can solve for theta, and you're gonna have that. Let's do tangent of theta. Let's not skip the steps. It's equal to cotangent of psi minus cotangent of phi all over 2. And this means that, right arrow here, theta is equal to tangent inverse of cotangent of psi minus cotangent of phi all over 2. Final answer. Now you have theta in terms of psi and phi. So final answer, and this is how we got here. So remember, how we got here, we have our two trigonometric functions and a drive to isolate theta. That's basically the trick of doing this whole problem.